Hello everyone. This is assignment group 3 and our assignment is on first machine learning application. Machine learning has three phases. The first phase is design and discovery, and the second phase is development of machine learning model, that is data preparation and model development, and third phase is business integration and organization change management. And regression. Regression is a statistical technique used in machine learning and data analysis to model the relation between a dependent variable and more than dependent variables. The goal of the regression analysis is to understand the quantify and how to change the independent variables are associated with changes in dependent variables. Linear regression. The relation between the independent variables and dependent variables is modeled as linear regression. The most common form of simple linear regression where there is single independent variable and multiple independent linear regression where there are multiple independent variables. So this is the equation of linear regression, that is y is equals to a plus bx plus where epsilon. So these are the uh, representation of the linear regression. Linear regression aims to find out the best fitting line that minimizes the sum of squared differences between the predicted values, and this is the end result. Next part will be continued by my friend Shravya. Thank you.
Ravya, unmute yourself.
Logistic regression is a statistical and machine learning model used for binary classification tasks where the goal is to predict one or two possible outcomes, typically represented as 0 or 1. Either it is a negative or positive class. Despite its names, logical regression is used for classification but not regression. It is used for predicting the categorical dependent variables using a given set of independent variables. It is simple yet powerful method for binary classification and serves as a fundamental building block in machine learning. Machine learning function. It map may be the real value into another value within a range of 0 to 1. Here we can see the graph. The value of the logical regression must be between 0 or 1. It cannot be beyond its limit. And here the curve we can see in the form of S shape. This is called the sigmoid function. And this function is only used in between the probability of 0 and 1. Next slide. When it comes to the classification between the linear and logistic, here we can see the graph. Even it's the same, but here the graph is totally different. The curve and everything. These are the end results of the examples that we have taken. We'll see in the execution part. Perception regression. This is a code. Here we have imported the weather history CSV. This is the another data set. When we scroll down, this is the head. And these are the columns that we are executing. And when it comes to the pre-processing of data, this is the complete information we have taken from it. And when it comes to the description of it, all the mean, count, STD, everything. When it comes to the shape here, we are executing here everything. And all the data pre-processing. And here we can see the x-axis and y-axis of the temperature. It depends on the year and the temperature. When it comes to the fit and predict evaluation, here we are training the perception model. This is a code that we are executing. When it comes to the predicting one, here we are defining the Y and B and evaluating the perception model. Here we are training the model with iterations 5 and printing the data. Here the end of the train, we can see that it's 96.072. And where here we are plotting the data. These are the end results that we can see here. And this is the graph. Here we can see it's a normal prediction line where the pink line represents that and the actual line is represented in the blue color. When it comes to the reshaping of X set and Y set, it's if needed. Here we can see the result is 8.69 something. And here in the end, we can say that the predicted temperature on 150 day of the year is 8.8. And next,
Yeah, next Darun will continue. Okay.
Yeah, hello. Now I would like to explain about polynomial regression. This algorithm of linear regression works only when the regression in the data is linear. Polynomial regression can be considered one of the exceptional cases of multiple linear regression models. In other words, it is a linear regression type containing dependent and independent variables, and they both share a curvilinear relationship, a polynomial relationship. Now my friend will continue.
These are the equations that we use to substitute in the linear, quadratic, and the cubic polynomials. These are the degrees, and for example, for the linear polynomials, we just use x. For the quadratic, we use the x square and x and the regular terms. And the cubic, we use the cube, square, regular x, and then the regular terms. And moving on to the next slide, we can see the end results of using the polynomial regression. Now my friend will continue. Let Srinivas explain about the code a little bit.
Yeah, these are the results of the polynomial regression. And we have these different kinds of, here we need to load the data set. Then we'll get the below output. And in the data processing, we have data pre-processing. And here we describe the results. Here there are no missing. I can cancel this.
here we can see that the values of target are distributed normally with few outliers. Here we can see the correlation matrix heap set according to the data set, and these are the features. And the correlation coefficient ranges from 1 to -1. The value is so close to 1. Here we can see the Y shape and X shape and the features. When it comes to the plotting of the data, here we can see the graphs, its differentiation between them. The prices increase as the value of RM increases linearly. There are few outliers here. When it comes to the Adeline algorithm, this is a This is a code.
Yeah, okay. Right now I will explain Adeline algorithm. Yeah, Adeline algorithm. Adeline algorithm is one of the adaptive linear neural algorithm is a machine learning algorithm that is closely related to the perceptron algorithm. Both are similar but different models. So here we do the step-by-step explanation about our LLM algorithm works, how it initialize, how it input the features like that. So initializing the weights of the coding basis threshold to show the small elements of like zeros like that. Choosing the learning data rate of hyperparameter that concentrate into the weight updates in each one and given a set of input features to the predictor are represented as a vectors like the when n is the main numerical features of this input features. So here we can see the Adeline algorithm how it actually works. A unit with a linear activation function is called as a linear unit. So in Adeline there is only one output and one output values are like bipolar plus one and minus one like that. These are all x1, x2, x3, x4 are from the new W rules like output input and input functions. And the learning rule of this is minimize to mean square and error between the activation target error consists of train weights so that output comes really like calculated output so that error training algorithm is not at all applied in that. First we calculate net input to the Adeline work and then we apply activation function to its output. Then compared to the original output, if both are equal, then give the output else and as a error back to the network. Now we are executing about the Adeline algorithm. We taken the Adeline algorithm or run the processing in using same host process dataset to the both Adeline and polynomial. So applying models for this data and performing your machine learning models to this data using the different regressions, evolution metrics, etc. We got MA like this. After that, we using the scikit-learn into the absolute errors, finding the model of accuracy to predict the align with the actual targets. And we pre-plot the things here. These are the plotting and this 3D visualization is relation between RM tags features and the target variable in 3D space. So that the regression plan represents the model's predicts and future values. These scattered data points are mainly shows the actual training data, which was we using on the data set. And this visualization can help any understand how well the model fits to the data. So this model is fits to the data and that's all from the Adeline regression. These are polynomial outputs. Thank you. Next, my friend will continue. Akhil, you can explain about this. Okay.
Okay, yeah, I'm here to continue about the perceptron, a machine-based algorithm used for the supervised learning of various binary sortings. Tasks is called a perceptron. And furthermore, perceptron also had an essential role as an artificial neuron or neural link in detecting certain input data, computations, and business intelligence. A perceptron model is also classified as one of the best and most specific types of artificial neural networks. Being a supervised learning algorithm of binary classifiers, we can also consider it a single layer neural network with four main parameters: input values, weights, and base, and net sum, and an activation function. So here we have some types of perceptron models. They are like, single layer perceptron model, one of the easiest artificial neural networks types consists of feed forward networks and include a threshold transfer inside the model. The main objective of the single layer perceptron model is to analyze the linearly separable objects with the binary outcomes, and a single layer perceptron can learn only linearly separable patterns. It has multi-layered perceptron model. It is mainly similar to a single layer perceptron model but has more hidden layers. Yeah, here we have the end results of this. Yeah. From here, my friend Karthik will continue.
Thank you. Yeah, these are the final one, the linear regression. We didn't show the execution of the linear regression, so we're showing the execution of linear regression algorithm. Importing the advertising.csv dataset from my desktop and running our results. These are the common representing of TV or a specific product campaign. So the radio newspaper cells, these are the datasets columns. We pre-processing the datasets here. And the results is running right now. And these are the plotting scatter plots in a single plot like data sets. And this is a correlation data set. From this scatter plot of heat map, we can see the sales TV higher correlations, set of TV higher correlation, these all things. So dropping unnecessary columns here. We don't need the unnecessary columns like TV sales so that we get a good model. And this linear regression, fitting the linear regression models and intercepting the coefficients. And these are the actual and predicted value of our core data sets. And it shows the scatter plot of showing the line of best fit, how many customers in a data sets we follow like that. These are the absolute square error and absolute square errors of end results we got here in the model evolution. That's it. That's it. All algorithms were executed. Thank you for the team. Thank you all once again. Thank you.